Here we have to study about the application of derivative. Now in this part, first one we have to study about the corresponding equation of tangent and normal. What is mean by tangent? Tangent is the line or line segment joining or intersecting the any one curve at one and only one point. Here in 10th standard we had studied about the corresponding tangents in the circle chapter. Now tangents are not only for circle, other standard curves are also there. For the any one curve, the line joining the corresponding circle or any one curve at any one point or intersect the point is called as a tangent. Now how to find the equation of tangent? We know that the equation of lines we have studied in the 11th also and standard in 10, 12 also. Now when line intersect here, therefore we know that the slope of the line is denoted by m. Here now I am showing this is a curve which is always, we can suppose it, y is equal to f of x, and therefore this line which is a tangent intersecting the corresponding circle at point. Now this is always a secant because it is always intersecting at 2 point. Now when this secant is always converted into tangent, then for this point q, which is always passes from this point to the corresponding this point, means q tends to p, means q is approaching towards p. At point p, the corresponding coordinates a f of a, means function is f of x, and at point x is equal to a, therefore y is equal to f of a. So a, f of a are the coordinates of point p. Now q, that point x is equal to b, here x is a plus b, means here a and this is total b, so this total b is equal to always there. So this distance which is called as here, this distance is h, this is total b, this is a, difference between b and a is equal to h. So a plus h is equal to b, so I can written here a plus h, this is the coordinates of at point here q, and f of y is equal to f of x, so if substitute x is equal to a plus h, so f of a plus h is the coordinate of y. Now here we know that if it is a continuous function, then at x present in the xy plane, then we had discussed about the point a p is equal to a f of a and q a plus h f of a plus h. Curve is equal to y is equal to f of x. Now join that is a pq when this is secant, when q approaches to p, before that one, what is the point p coordinates and q coordinates? We can find the distance, or using the slope formula y2 minus y1 upon x2 minus x1. This is studied in the 10th standard. Now according to this slope of the chord pq, it is given by f of a plus h minus f of a divided by a plus h minus a. This is y2 minus y1 upon x2 minus x1, and therefore f of a plus h minus f of a divided by h, a is cancel. Now this is the existing slope of this one, but it is slope which is always for the given secant pq, but q is approaching towards p, so you have to exist the limit as q approaches to p, means q tends to p. Now this is point taking here, we have to take here limit at x tends to a, so here x p q tends to p, so distance can decreases towards 0, so h approaches here limit at h tends to 0, f of a plus h minus f of a divided by h, because when here b always q approaches to p, then Therefore, distance with decreases. So h tends to 0. So I had taken here limit at h tends to 0, f of a plus h minus f of a divided by h. Existing limit, that is first principle of derivative formula, f of a plus h minus f of a divided by h is equal to f dash a. And this is a f dash a. So existing limit of this function, which is a slope, which is always denoted by now f dash a. And so therefore the slope of PQ is equal to f dash a, or that is y is equal to f of x. So we have to be right, therefore derivative dy upon dx. Means here when q approaches to p, therefore the secant is converted into tangent. So we had got the corresponding, this is a slope, is nothing but it is a always derivative of the original function f of x at point A. Now that point A, therefore we had got dy by dx, and therefore which is always we can use this slope and for given coordinates which are a f of a, q f a plus h f of a plus, using therefore any one point of this part. Now we have to find the equation of line now, which is it converted into tangent at point P. So I will take x1 y1. So we know that formula y minus y1, therefore y minus y1 is equal to dy upon dx in bracket x minus x1. Slope point form we have studied in the 10th standard. Y minus y1 is equal to m in bracket x minus x1, but instead of m I will consider dy by dx as a slope. So equation of tangent at point P xy, any point at the curve, then the equation of the tangent at point P is y minus y1 is equal to dy upon dx in bracket x minus x1. Now normal is a line which is perpendicular here. When we can take here perpendicular line, this is a normal. So normal is the line perpendicular to the tangent. So lines are perpendicular, then product of the slope are always therefore reciprocal of each other. Means dy by dx is the slope of the tangent, then slope of normal is minus 1 upon dy upon dx. So taking this slope, I will take here equation of normal y minus y1 is equal to minus 1 upon dy upon dx in bracket x minus x1. So converting this one equation in the standard form ax plus by plus c is equal to 0, we can get here equation of tangent as well as equation of normal.